Welcome to Chapter 14, JIT, J-I-T, Just in Time, and Lean Operations. We're on page 608. On page 609, Lean Operations. It's a flexible system that uses minimal resources and produces high-quality goods or services. Lean Operations. Just in Time, JIT, J-I-T, is a highly coordinated processing system in which goods move through the system and services are performed just as they are needed. The nice thing about this chapter is really going to talk a little bit about manufacturing, but it applies to service at least as much. On page 610, characteristics of a lean system. There are a number of characteristics that are commonly found in lean systems. An overview of these will provide a better understanding of the lean systems. But the very top one is waste reduction. It's the hallmark of lean systems, waste reductions. Under the 5 principles that embody the way lean systems function, you'll note the connection to the preceding characteristics above is number 1, identify customer values. Identify value from the customer's point of view. I'm a charter captain, and I kind of have a little fun with some of the other charter captains where they say, I don't like to use live bait. And what I say is, doesn't matter what you like. Nobody cares what you like. Because really, what really matters is, what is the customer value? And if the customer values catching more fish and live bait is the ticket, you better go with what's important to the customer, because nobody really cares what you like. Might have had that conversation a couple times with some of the younger guys. On page 611, some benefits and risks of a lean system. First and foremost, reduced waste due to emphasis on waste reduction. That's a benefit. You have less waste. No ifs, ands, or buts. This is all based on the Toyota Production System, TPS. So under the Toyota approach, down toward in the middle, one of the things they say that they really focus on is MUDA. M-U-D-A, MUDA, is waste and efficiency, perhaps the driving philosophy. Waste and inefficiency can be minimized by using the following characteristics: Kanban, Heijunka, Kaizen, Jidoka. We'll talk more about those. And what's kind of nice is a lot of people really enjoyed this chapter. It hit home to a lot of folks, myself included, having spent my last 30 years in industry in continuous improvement. On page 613, under supporting goals, the ultimate goal of lean is a balanced system. That is, one that achieves a smooth, rapid flow of material and or work throughout the system. And how can you tell when that's happening? When you eliminate disruptions, you make the system flexible, and finally, eliminate waste, especially excess inventory. Keep that in mind. That's the overall waste that the Toyota Production System really focuses on, is excess inventory can really hide all the other waste. So down towards the bottom, they talk about the 8 wastes. I like to do this in class better, but actually, I'll do it right now. I think that's backwards to you, but oh well. It says Tim Wood. Tim Wood. Those are actually the 7 waste other than underused people. So T for transportation, I for inventory, M for motion, W for waiting, O for overproduction, O for processing, and D for defects. And you can see how they relate to the wastes on the bottom of page 613. So there's a good mnemonic device to remember the 7 wastes. Tim Wood plus underused people. In my book, I've got all kinds of little diagrams that I use when we're doing this in class, and little sayings that we had in continuous improvement. Like one of them was, we like to learn by doing. Learn by doing. You know, you don't learn much in a conference room, but you learn an awful lot when you go out to the shop floor, to the environment, in a service environment. Let's go to where that transaction really takes place. You're a teller at a bank. Let's go to your actual station and show me how that could happen. Oh, yeah. I didn't think that. So we like to learn by doing. On page 614, under building blocks, talks about the design and operation of a lean system, providing the foundation for accomplishing the aforementioned goals. Are you need good product design, good process design, you need personnel and organizational elements, and you need manufacturing planning and control. Personnel and organizational elements. It's a big deal. Some of you may have heard the story about Toyota came to the U.S. They bought a plant. NUMMI, out in California, was the worst plant that General Motors had. Well, what Toyota did was they fired about 10 people out of 5,000. And those were people that were selling drugs, etc. And anyways, with the right training, the right expectations, it went from being GM's worst plant with help from Toyota to being their very best plant. So not saying they do everything perfect, but my old boss used to say, you know, when he heard somebody say, one of his plant managers would say, boy, I got good people. He'd say, I hate to hear that. I hate that. So what do you mean you hate that? They got good people. He goes, everybody has good people. Everybody has good people. You show me a facility that's got problems, I'll show you a facility that's got leadership issues. So same thing with that NUMMI plant, is it starts with leadership. Talk about automation on page 617. Automation, we always said it's automation with a human touch. It's automatic detection of defects during production. Some of you may have heard the story of where that came from, automation. It used to be in Japan, one operator could run one little spinning mill making fabric. Because what would happen is if the string broke, that piece of fabric was no good. So somebody had to be there watching to see if it broke. Well, what they ended up doing is figuring out a system where it would tell you when the string broke. When the string broke, poof, the machine stopped and a flag went up. And that's where and-on comes from. That's an and-on signal, which tells you when you have an out-of-control situation, when you have something happen that you don't want. And that's really what you want in a lean system. You know, I would always have to teach folks, we want the inventory so low that if anything bad happens, you have to stop. Anything. So, well, why would you want that? Because that gives us an opportunity to fix things. We don't want to have that excess inventory. We don't want to have a situation where things can go wrong, but they don't get addressed. Page 618 in the middle, tact time. Tact. Tact is actually means beat. It's a German, comes from a conductor, tact, beat. And in manufacturing, it refers to the cycle time needed to match customer demand for final product. We would always say it's easy as A, B, C. It's your available time divided by customer demand. Tells you how often you need to deliver a product in your facility to meet customer demand. And it's usually in time, and ideally in seconds. On page 620, poka-yoke. Poka-yoke. Safeguards built into a process to reduce the possibility of errors. This is something I tried to work on whenever I could. The analogy I would use, the difference between McDonald's and Burger King. At Burger King, they put a sign up, said, please don't throw your trays away. And they would have them on all sides of the trash can and behind it. Please don't throw your little tray away. What McDonald's do? McDonald's made the opening to the trash can just small enough that a tray couldn't go in there. That's poka-yoke. That's error proofing. That's making it so bad things can't happen. On page 621, problem solving. Problem solving is a cornerstone of any lean system. One of the things that we had at our plant was called, I won't take an error, I won't make an error, I won't pass an error. That was part of our problem solving methodology, is because I wanted to find out at the source if we had an issue. So if I see something that's not right coming to me, stop the process. If I can't make it the way it's supposed to be, I stop the process. If I'm trying to send it to the next operation and it's not right, stop the process. When in doubt, stop the process. Because guess what? When you stop the process, things get a lot of attention in a hurry, which is a good thing. On page 622 at the top, Andon. Andon is a system of lights used at each workstation to signal problems or slowdown. At the facility I worked at, we had a very sophisticated help chain that was based on a hospital system where you were able to call for help. And we actually monitored then how long it took you to get help. We had people that were responsible. We had first level, second level, third level, fourth level would be the plant manager. If it didn't get solved within, might be 12 hours, it went to the plant manager. If it wasn't solved within 5 minutes, it went to the department supervisor. So, Andon. Signal problems or slowdowns. Oh, you're missing all my little notes here. On page 631, under Lean Tools, Value Stream Mapping. Value stream mapping is a visual tool to systematically examine the flow of materials and information involved in bringing a product or service to a customer. Value stream map. And we always used to say, if you can't draw it, you don't understand it. And when doing a value stream, just one of my little notes here, if you're ever going to do a plant tour of a plant that you're not real familiar with, always encourage you to walk the process backwards. Let's start in shipping. Okay. Oh. And you keep going backwards. You look at the plant from a whole different way. Try that sometime. On page 633, under planning a successful conversion, like in most change efforts, if not all, make sure top management is committed to the conversion, that they know what will be required. Top management. Just like the example with my boss, you show me an operation that's got trouble, I'll show you an operation that's got leadership issues. Obstacles to conversions. If it's such a great idea, why doesn't everybody do this? Manufacturers that operate with large amounts of inventory to handle varying customer demand may have difficulty acclimating themselves to less inventory. I don't know what the customer is going to order. We always used to say 25% of our schedule changed based on customer demand every week in a month. So in a 4-week month, if 25% changes each week, that's 100% change from what you started. The case you'll have with this chapter is on page 641, level operations. And you only have one question. What might Stephanie determine as the best production quantity per cycle for each day of the week? Very basic. I think you'll have a little fun with that under level operations. All righty. I hope you enjoyed Chapter 14. Next we'll be covering the supplement, but in the meantime,